हेलो माय डियर स्टूडेंट्स, कैसे हो? वेलकम टू द सेशन। कैसे हो? आ गए सारे के सारे? मेरी आवाज आ रही है आपको? आर यू एबल टू हियर मी? यस, आई एम विजिबल एंड ऑडिबल टू ऑल ऑफ यू। ओके, थ्री वॉचिंग यानी कि टू वॉचिंग। वेयर आर द अदर्स? The session that we are talking about today is extremely important session. We are going to talk about hybridization today. So hybridization is something very important. You are not supposed to miss it. So we have Teethraj, Prerna, Faiza Khatun, Akshay Thakur, Radhika Mittal. But why is it showing? Okay, now it is five watching now. गुड इवनिंग अमी गौतम, बहुत दिनों बाद नजर आए। और देखो मैं आपको एक बात बता देता हूं कि टुडे वी आर गोइंग टू हैव द डिस्कशन ऑफ द टेस्ट पेपर एट 8 पीएम। 8 पीएम वी आर गोइंग टू हैव द डिस्कशन ऑन गूगल मीट। वी आर गोइंग टू डिस्कस द टेस्ट पेपर ऑफ ईच एंड एवरी स्टूडेंट एंड वी आर गोइंग टू हैव द कंप्लीट डिस्कशन व्हाट एग्जैक्टली यू आर getting and why you are getting that. Is that okay? So what you are getting and why you are getting, that's what we are going to discuss in the class. Okay. So let's begin over with bonding and molecular structure and we talk about hybridization. किसी को कुछ पूछना है आज की पहले की क्लास के अंदर? So we have some new students also like Faiza Khatun, but she has left the session, I believe. Okay, Ami Gautam. And let's begin over with it. This is the Elixir Droppers batch. So you have to join with it. You can use the code AVLIVE. Use the code AVLIVE and join with us. Clear hai Prerna sab kuch. Prerna, you have attempted it second time also and you have same kind of a score, but you were attempting it when I saw it. Akshay Thakur ne attempt kar liya hai, but Akshay Thakur has got lesser score as compared to Prerna. Prerna has a higher score. And Teethraj, you have also attempted the paper, but you have even a lower score. Why? Okay, fine. We are going to discuss the questions today and we are going to have a test paper tomorrow as well. ठीक है ना? मुझे टेस्ट पेपर बनाने में कोई टाइम नहीं लगेगा. So Elixir Droppers batch is in-depth analysis of PYQs, revision classes, and exam strategies, mentor-mentee program, and the code is AVLIVE. And please remember, you have to get it from the Unacademy store. If you want the entire Unacademy subscription, that is available on the app. But if you want the specific course, you have to go to Unacademy store to get that particular subscription. Okay. Now, this is what we have as Elixir Droppers batch for NEET. 6:30 to 7:30 p.m. is Swati ma'am. 7:30 to 9 p.m. is me. 1.5 hours, 90 minutes. 9 p.m. to 10 p.m. is Sachin sir. So this is what we have as Elixir Dropper batch. 15,199. थोड़ा सा महंगा हो गया, isn't it? Get all the सवाल जवाब on 6366950726. WhatsApp कर दो, पता चल जाएगा. Tomorrow's topic, molecular orbital theory. So tomorrow morning we are going to do molecular orbital theory and the test topic is again the same one as today. That is chemical kinetics and the some basic concepts of chemistry because you have not got the marks which I expected. Again 40 questions. Again no limit. Again everything the same. Morning 5 o'clock the test is going to be open. तो बेटा उसे तैराओ तीर्थराज, ये कहने से कोई मतलब नहीं है कि बेसिक कंसेप्ट्स ऑफ केमिस्ट्री चैप्टर डूबा हुआ है तो तुम मजे ले रहे हो. डूबते डूबते डूबा डूबा देश बैठा हूं, वो वाला गाना नहीं गाना तुम्हें. डूबा डूबा बैठा हूं, जागे रहो, उगो, तैरो. Okay, that's me, MSc in chemistry, 26 years experience. So let's get along with something called hybridization. Now, when we talk about the hybridization, let us understand certain very, very, very important things about hybridization. Clear? First thing, हाइब्रिडाई Z है या S है, मर्जी है आपकी, हाइब्रिडाइजेशन. ओके, संकरण, संकरण. ओके, मिक्सिंग अप. Hybridization means mixing up. Okay. Before we get along with what is hybridization, let us talk about where we use hybridization. The very first thing, it is of atom and not the molecule. हाइब्रिडाइजेशन एटम का होता है, मॉलिक्यूल का नहीं. वेलकम अनन्या. अनन्या, हैव यू अटेम्प्टेड द पेपर? आई डोंट थिंक सो. देखना पड़ेगा. अभी 7 अटेम्प्ट हुए हैं टोटल, जिसमें से 2 अटेम्प्ट तो प्रेरणा की ही है. ओके, दिस इज ऑफ एटम एंड नॉट ऑफ द मॉलिक्यूल. अच्छी तरह डाल लेना. Different atoms in the same molecule can have their own hybridization. ठीक है, समझ में आ गया? हाइब्रिडाइजेशन एटम का होता है, मॉलिक्यूल का नहीं होता. अलग अलग एटम्स का सेम मॉलिक्यूल के अंदर डिफरेंट हाइब्रिडाइजेशन हो सकते हैं और होते हैं. समझ आ गई बात? तीसरा, थर्ड वन, no hybridization for terminal or peripheral atoms. पेरिफेरल और टर्मिनल एटम्स का हाइब्रिडाइजेशन नहीं निकाला जाता. समझ आ गई बात? Okay, we do not find the hybridization for terminal or peripheral atoms. Clear? Fourth point, hybridized orbital energy can be calculated. Yes, we can calculate the energy of the hybridized orbitals, but cannot be measured. Okay? Simply speaking, hybridization does not exist. Okay? Hybridized orbitals cannot be observed. Ananya, yes, NEET is not going to wait for us. That is why we have already started the question series. Okay? So hybridized orbital energy can be calculated but cannot be measured. Hybridized orbital cannot be observed. So hybridization does not exist. Okay? Now let us see, why do we need hybridization? Why do we need hybridization? आराम से करेंगे, जल्दी से नहीं करेंगे, बहुत ढंग से तसल्ली से समझ के करेंगे. Okay. Let's get along with BECS. BeCl2. Now, this is the simplest molecule there we talk about hybridization, BeCl2, beryllium chloride. Because before that, we have the molecules in which we have only two atoms. Both the atoms are terminal atoms. We do not find the hybridization of terminal atoms. Okay. Now, when we talk about BeCl2, what are the steps in hybridization? What are the steps in hybridization? The very first thing, you have to make the Lewis dot structure. Let's make the Lewis dot structure. Anybody who has not liked the session, go ahead and like it. I believe there are only 7 people here in the session and everybody has already liked it. No, one is there who's not liked it. Okay, because one of the like is mine also. So there should be 8 likes. जिसने like नहीं किया जल्दी से like करो. So you have to make the Lewis dot structure. We have Cl 1, 2, 3, 4, 5, 6, 7. Here we have beryllium 1. And here we have again the another Cl 1, 2, 3, 4, 5, 6, 7. Okay, so that's what we have as a Lewis dot structure. Okay, now once we have found that, we have to find the steric number. Steric number here is 2. Structure, we know it's linear. Okay, now once we have made the Lewis dot structure, now let's talk about how the bonds are going to be formed. Now we have beryllium. Now we have something called the ground state configuration. Ground state configuration. What is the meaning of ground state? Let's understand what is the meaning of ground state. The lowest energy state of the system. The lowest energy state of the system is termed as the ground state. Khatam. Okay. If you want to change the state of the system, if you want to change the energy of the system, then in that case, you will have to provide some energy to the system and it will go into some other state. That energy state will be higher than the ground state. And that energy state is called the excited state. Okay. Any state other than the ground state. That is called the excited state. Great, Ananya. I'll just check it out. And we are going to discuss each and every student in the class at 8 p.m. in Google Meet. I'm going to send you the link of Google Meet and we are going to study and share each and every session. Please remember, हर किसी का पेपर डिस्कस होगा और हर किसी के सामने डिस्कस होगा. I hope you don't mind that. ठीक है, आपने जो गलतियां की है वो आपको बताई जाएंगी, सबको बताई जाएंगी, सबका पेपर एक साथ डिस्कस होगा. कितने बच्चे हैं हमारे पास? कुल मिला के 7 बच्चे तो टोटल हैं, इस समय तो 4 ही हैं. ठीक है, सो आई होप यू आर नॉट गोइंग टू माइंड ईच अदर. So we'll discuss each and every person's attempt and why they made a mistake, where you need to see कि तुमने क्या गलती की, कैसे पेपर एनालिसिस करना है वो बताऊंगा आपको. How paper needs to be analyzed. ठीक है. Now, any state other than the ground state is called the excited state. We can have first excited state. We can have second, we can have third. The energy state just above ground state. Okay, that is the next energy state to the ground state is called the first excited state. To that, next is second excited state. To that, it is third excited state. Remember, first excited state is actually second energy state. Okay, first excited state is actually second energy state. समझ में आ रहा है? Excited state का मतलब, ground state का मतलब. So here we have the ground state electronic configuration of beryllium. Now, beryllium electronic configuration, we only talk about the valence shell. We do not talk about any other shell. We do not talk about the core electrons. The valence shell becomes beryllium ground state is simply 2s2. So this is the electronic configuration of beryllium. Okay. And here we have the p subshell, which is empty. 2p is empty here. So this is 2s2, 2p0. Fine. Now, the Lewis dot structure tells us that beryllium shares one electron each with the two chlorines. So quite obviously, the Lewis dot structure tells us that beryllium must have two unpaired electrons. Fine. So beryllium must have two unpaired electrons to share with chlorine. So beryllium actually has two electrons which are paired. I need to unpair these electrons. Okay. So the atom must have enough unpaired electrons to make normal कोवैलेंट बॉन्ड्स. ठीक है. अगर नहीं है तो एक्साइट करो. If required unpaired electrons are not available, then excite the electron from highest energy fully filled orbital. Now, highest energy fully filled orbital means orbital with electron pair. Orbital with electron pair 2. The lowest energy empty orbital. सुशांत प्रचंड बेटा 2p ब्लॉक पेड और अनपेड मैं समझा नहीं. 2p ब्लॉक पेड और अनपेड नहीं समझ में आया बेटा. पेयर्ड और अनपेड बोल रहे थे या पेड और अनपेड बोल रहे थे. ओके. तो यहां से व्हाट आई नीड टू डू इज I will have to shift this electron from this to this. Okay. So fully filled 2s2 to empty 2p. तीसरा सुशांत को ही बोलने दो बेटा. Why should we try to predict it? What he's saying? Let him say it. Fine. So here we get an excited state. Now what is an excited state here? Here is going to be 1, here is going to be 1. So this is 2s and this is 2p. So we have now s electron having 1 electron and p also has 1 electron. So this is what we have as excited state. Okay. Now we have to create the bond. Bond. Now, when I create the bond, then in that case, s orbital is going to form one bond and p orbital is going to form another bond. Okay. The s orbital is different from p orbital. Its energy is different. Its orientation is different. So these two bonds are supposed to be different. But what we find is that in the case of beryllium chloride, both the bonds are exactly identical. Okay, both the bonds are exactly identical. So what we consider is that the lowest energy valence shell orbitals mixed together to form hybrid orbitals. Clear? Now we talk about something called hybridization definition. Hybridization. What exactly hybridization means? Hybridization is mixing of atomic orbitals having similar, and similar is very important. जितना एनर्जी गैप होता जाएगा हाइब्रिडेशन उतना मुश्किल होता जाएगा. Having similar energy to give a set of orbitals having same energy. Okay. So hybridization is mixing of atomic orbitals having similar energy to give a set of orbitals having same energy. Similar to same. समझ आई ये बात? Fine. That is what we call as hybridization. अब एक बात का ध्यान रखना. Orbitals participating in hybridization may be fully filled, half filled, or empty. Okay. Number of orbitals participating in hybridization is equal to steric number. Okay. Number of orbitals participating in hybridization is equal to the steric number. Whatever is the steric number, that is the number of orbitals taking part in hybridization. ये बात समझ में आई? Number of hybrid orbitals formed is the same as number of orbitals participating in hybridization. So जितने ऑर्बिटल्स हाइब्रिडाइजेशन में पार्टिसिपेट कर रहे हैं उतने ही ऑर्बिटल्स हाइब्रिडाइज्ड बन रहे हैं, मतलब कि सेम एज स्टेरिक नंबर। समझ आया? ठीक है। नाउ हाइब्रिड ऑर्बिटल्स orient themselves as per VSEPR. That is, they orient themselves in such a manner that they have minimum repulsion and they are the most stable. That is the maximum angle, minimum repulsion. That is how they arrange themselves. Any confusions? किसी को कुछ पूछना है? So, here when we talk about, this is going to be taking part in hybridization. Steric number 2. So that's going to be two electrons, two orbitals taking part in hybridization. There is one s orbital and one p orbital. So it is going to be one s and one p orbital. It is going to be sp hybridization. So what we have as hybridized state. The hybridized state is going to be, these are the two orbitals. This is one sp orbital. This is one sp orbital. This is the remaining two p orbitals. Okay, so we have the two sp hybridized orbitals. Now, when I make the structure of beryllium chloride, so when I make the structure of beryllium chloride, hybridized orbital ke saath, then in that case I make it like this. This is beryllium. This beryllium has one hybridized orbital like this. Okay, another hybridized orbital like this. Okay, and then we have two chlorine atoms. Now, chlorine is a terminal atom, chlorine is a peripheral atom. We do not talk about hybridization of the chlorine atom. This is one sp hybridized orbital. This is another sp hybridized orbital. And then we have chlorine. So here we have one chlorine atom. Here we have another chlorine atom. And here are the orbitals of chlorine. This is one p orbital of chlorine. Okay. This is the p orbital of chlorine. This is the p orbital of this chlorine. So this is a p sp bond. This is an sp p bond, and this structure Cl Be Cl has an angle of 180 degrees and it has a hybridization of sp. Any confusions here? So that is the structure of beryllium chloride. Fine. Any kind of confusions here? So that's what we have as hybridization of beryllium chloride. Now let's talk about something like carbon dioxide. There isn't any 11th class student here, otherwise that would have been much better. Okay, let's talk about carbon dioxide. Carbon dioxide, we have carbon, No, we'll make the Lewis dot structure. Yeah, see, this is the carbon dioxide का पहले Lewis dot structure बना लेते हैं. This is the Lewis dot structure of carbon. Now the steric number is again 2 of carbon. When the steric number is 2, it is very much clear that the hybridization is going to be sp. The steric number itself tells you the hybridization. Nothing to do with it. Hybridization is simply the steric number. What you can do is you write it S, P, 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 D, 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 D. Okay. Now here, steric number 2, steric number 3, steric number 4, steric number 5. So here steric number 2, it is sp. Steric number 3, it is sp2, 1s and 2p. Steric number 4, S1 and P3. Steric number 5, S1, P3 and D1. sp3d. Steric number 6, एक S, P के 3, D के 2. हो गए 6. Steric number 7, S का 1, P के 3, D के 3. कोई confusion? So make the Lewis dot structure, find the steric number and give the hybridization. कोई confusion? So that is structure of carbon dioxide. Now let's see some structures. देखिए कुछ structures. So here is something called the azide ion. That is what you can see, the azide ion. Clear? Now here, this nitrogen is sp hybridized. This is the azide ion. Any confusions with it? This is the structure called hydrocyanate acid. Ami Gautam, in morning class we did something like azide ion. Azide ion is N3 minus. ठीक है ना? You can even consider thiocyanate like this or cyanate like this. Hello Piyush, how are you? What happened? That's the azide ion. This is the structure of hydrogen cyanide. Any confusion? This is hydrogen cyanide. हाँ जी. This is what we have as a carbon dioxide. हाँ नन्या, इसमें दो पाई बॉन्ड्स हैं. This is the structure of BF3. Any problems with this structure of BF3? This is the structure of SO3. कोई confusion? What is the hybridization of SO3? This is NO3 minus. So this is NO3 minus. What is the hybridization? So it has the hybridization of sp2. चलो एक काम करते हैं. Now we are going to talk about the various structures and you are going to give me the hybridization of these. Clear? Okay, सारा का सारा लिखते जाएं. Okay, what's the hybridization here? We are going to talk about the hybridization of phosphorus here. This is the structure of phosphate ion. Hybridization. Here the angle is 109 degree 28 minutes. It's actual tetrahedral structure. Is that clear? The structure is HSO4 minus. Hydrogen sulfate ion. Now here we have two things, two atoms which hybridization we can find out. We can find out the hybridization of sulfur and we can find out the hybridization of oxygen, which has two atoms attached to it, one sulfur and one oxygen, one hydrogen. So what is the hybridization of sulfur? You need to find out the steric number. राधिका मित्तल sp3d कैसे हो गया? Teethraj, how did you get sp3d? एक एटम यहां है, एक एटम यहां है, एक एटम यहां है, एक एटम यहां है. There are 4 atoms attached to sulfur and sulfur does not have a lone pair. Steric number equal to 4. So hybridization should be equal to sp3. How did you get a D? And this oxygen has the hybridization again of sp3. It has 2 lone pair plus 2 atoms. इसका भी steric number is 4. प्रीवियस का था, प्रीवियस में भी sp3 ही हाइब्रिडेशन था बेटा, sp3d तो था ही नहीं. जबरदस्ती sp3d का तो स्ट्रक्चर हमने अभी तक किया ही नहीं है. कुछ भी ना. कुछ भी चलता है. तुक्का मार दो, संभाल लेंगे. CH3Cl. CH3Cl. What is the hybridization of carbon? Hansika beta, why don't you join the Telegram channel and the WhatsApp group? I sent you the messages on WhatsApp group and the Telegram channel. So join the Telegram channel and WhatsApp group and you will get all the notifications without any problems. Now just remember this angle is actually smaller than 109 degree 28 minutes. Why? Because hydrogen, which is a less electronegative atom, repels. Okay? The more electronegative atom repel more and their angle turns out to be greater. क्योंकि less electronegative atom के अंदर the electrons shift towards the central atom, while more electronegative atom pulls out the electron towards itself. Is this clear? Now these are the two possible structures of sulfate ion. You can consider that the sulfate ion is forming all the four bonds. Two of them are coordinate bond, two of them are normal bonds. Either you can make it that way, or you can consider that sulfur is forming the double bonds, two double bonds and two single bonds. Okay, what is the hybridization of sulfur? What is the hybridization of sulfur in it? Okay, I have sent you the link of the meet. आकाश पाटवा कह रहे हैं सर होमो लूमो क्या होता है? अभी बताया था बेटा. होमो एंड लूमो इज हाईएस्ट ऑक्यूपाइड molecular orbital, and LUMO is lowest unoccupied molecular orbital. Okay, so that's what we have as HOMO and LUMO. We are going to explain that when we talk about the molecular orbital theory. And molecular orbital theory we are going to talk about in tomorrow morning 10 o'clock. Okay, so that was the sulfate ion. Now this is what we have as the perchloric acid. Perchloric acid. Anything you want to ask here? In perchloric acid, chlorine oxygen bonds are not identical because one of the oxygen has hydrogen attached to it. The three bonds are perfectly identical and the fourth bond is longer. Can you see that? अरे equilibrium. बॉन्डिंग खत्म करने के बाद फिर से इक्विलिब्रियम शुरू करूंगा. नहीं, केमिकल इक्विलिब्रियम अभी ओवर नहीं हुआ है. We have to talk about the effect of the gases, inert gas. Dr. Akash Patwa, you have not seen the class in the morning. Go ahead and see the class in the morning. You will be able to understand. We are going to name the structures there. So this is what we have as perchloric acid. Anything you want to ask here? This is what we have phosgene. What is the hybridization of carbon here? जल्दी जल्दी हाइब्रिडेशन बताते चले जाओ और इसको देखते चले जाओ. What exactly you want to ask? As you can very well see, here carbon oxygen double bond is there. The bond angle actually becomes a little bit more in case of chlorine carbon chlorine bond because of the repulsion between the two. It is becoming less actually. It should be 120 degree, but it has become 111 degree. Why? Because the oxygen double bond, this repels more. Okay. So highest repulsion is of lone pair, followed by multiple bond, followed by less electronegative atom. Is it clear? Highest repulsion is of the lone pair, followed by the multiple bond, followed by less electronegative atom, and then the more electronegative atom. अरे भैया, carbon here is sp2 hybridized, not sp3. The steric number here is actually equal to 3. So it is sp2 hybridized. How are you making it sp3, Akshay Thakur? Now this is the beautiful structure of iodine heptafluoride. This is what we know as pentagonal bipyramid. IF7. कुछ पूछना है इसमें? Can anybody tell me how many 90-degree angle does it have? कितने 90-degree angles हैं? Steric number 3. Ananya, iodine heptafluoride. Steric number is 7. Iodine heptafluoride, the steric number is 7. हंसिका, आज सुबह वाली क्लास देखो. स्टेरिक नंबर क्या होता है? स्टेरिक नंबर इज एक्चुअली द सम ऑफ द नंबर ऑफ एटम्स अटैच्ड टू अ गिवन एटम एंड द नंबर ऑफ लोन पेयर्स. सो दैट इज व्हाट वी कॉल अ स्टेरिक नंबर. 90 डिग्री के 10 एंगल्स हैं. 10 है 90 डिग्री के एंगल. बेटा यहां पे ये जो आयोडीन है ना हमारे पास, ये जो आयोडीन है, ये हमारे पास आयोडीन है ना, ये हमारे पास एक पेंटागन बना है. ये यहां पे ये जो ना, ये सारे एंगल 90 डिग्री हैं. ये सारे एंगल 90 डिग्री के हैं. These all angles are 90 डिग्री. समझ आई? समझ आ रहा है अनन्या? देयर आर 10 90 डिग्री एंगल्स. ये देखो पेंटागन ये है ना, एक ऊपर है और एक नीचे है. समझे? Is this clear? So that is IF7, pentagonal bipyramid, 10 90 degree angles, 5 72 degree angles and 1 180 degree angle. जी बिल्कुल राधिका, SF6 में 90 डिग्री के 12 एंगल्स हैं. ठीक है? Now this would be structure of PCl5. Now PCl5 has how many 90 degree angles? How many 120 degree angles and how many 180 degree angles? नाइन्टी डिग्री के कितने एंगल इसमें PCl5 में? How many 90 degree angles are there in PCl5? I have already shared with you the link to the today's Google Meet class where we are going to discuss the question paper. The paper that you are supposed to give, supposed to take, it's already there on the site. Go ahead and take that paper so that we can discuss it. And this is how we are going to discuss each and every paper that you take. There are 6 90-degree angles. How many 120-degree angles are there? How many 120-degree angles? Yes, we have one 180-degree angle, three 120-degree angle. This is what we have as PCL5. PCL5 is trigonal bipyramid. That's what we have as PCL5, trigonal bipyramid. Now that's what we have as SF6. जरा गिन के बताना SF6 में कितने 180 डिग्री 90 डिग्री के एंगल है और कितने 180 डिग्री के एंगल्स हैं? रोशन कुमार सर, आप फिर अनअकैडमी क्यों आए? आ गए हम? आपने बुलाया और हम चले आए? There are 12 90-degree angles. And how many 180-degree angles? There are three 180-degree angles. And this is what we call as octahedron. Clear? That's SF6. This is what you can see, PCL5. Now this is the structure of BRF5. Now this is what we call as square pyramid. Can anybody tell me how many 90-degree angles does it have? BRF5, how many 90-degree angles does it have? What is the hybridization of BRF5? sp3d2. How many 90-degree angles? कितने हैं? 10. 10 कहां से आ गए अनन्या? sp3d2 तो ये है. हंसिका, you can get it on a playlist. Unacademy NEET Elixir की playlist में मिल जाएंगी आपको सारी classes. It is 0 due to repulsion by the lone pair. The repulsion by the lone pair makes this angle, every angle less than 90 degree. There is no 90-degree angle here. Is it clear? So that's what we have as BRF5. Now let's talk about CLF3. It's what we call as T-shaped. What is the hybridization? What is the hybridization? sp3d. Steric number 5, 2 lone pairs and 3 atoms. एक बात का ध्यान रखना. When we talk about a trigonal bipyramid, when we talk about the trigonal bipyramid, these are the equatorial position. And this is the what we call as axial position. Axial positions are more repelled. Axial positions are more repelled. So every atom tries to be at the equatorial position. Now, equatorial position is according to the repulsion. The first priority is of the lone pair, then the multiple bond, then the less electronegative element. Is that clear? Right, you are. Is this clear? Now here is ammonia. सारे गायब हो गए. चलो कोई नहीं. So at 2 p.m. we have botany. 3 p.m. zoology. 4 p.m. chemistry. Join our Telegram channel for YouTube classes PDFs, t.me/NEET Elixir. And tomorrow morning, we have the session at 10 o'clock of molecular orbital theory. I don't know, but I'm not able to see anybody. कोई बात नहीं, चलो. We have ended the session, and tomorrow we are going to start with molecular orbital theory. I believe we have talked about the hybridization enough. There should not be any problem. Okay, maybe the glitch. Let's see. Unacademy app, Learner app, Unacademy. Join with us on the Unacademy Learner app and join with me on unacademy.com/Anoop Vashishtha. ठीक है? 8 बजे we are discussing the question paper. ठीक है? The 40 questions that you have attempted, we are going to discuss for each and every student. याद रखना, the link is already on the group, so join with it. Okay? NEET Elixir by Unacademy for the best live classes. Bye-bye. We are going to meet at 8 p.m. today. Clear? The link is already with you. Google Meet link. Okay? Bye-bye.